Okay, enough about fish and the hunting regulations. Next one we'll talk about are trees. Something that we use a lot of in many different contexts, even if you don't realize that what you're using is trees. So here I have a picture looking at a mountain range, and we have kind of these two mountains. One that's completely forested, and one that has been what we call clear cut. And clear cut is just, you pretty much take all the trees. And that makes you a lot of money, right? If you chop down 10,000 trees, let's say you get $1 for each one, that's $10,000 at once. That's awesome. And this is why it happens. Same with overfishing. The reason overfishing happens is if I get $1 for every fish I catch, hell yeah, I'm going to catch as much fish as I can. But there comes a problem with clear cutting. Problems that affect us as humans as well as the environment. So one, if you take down all the trees, that means there's no trees to drop seeds. Trees are a renewable resource. They grow back. But if there's no seeds in the area, how are they supposed to grow back? And so that's the issue, is that, they'll come back, but if you have nothing to support them, not just the seeds themselves, but then also protection. Especially if you're on mountains, it's very windy. Lots of water depending on the side of the mountain that the tree is. Well, they don't have protection from other trees to kind of help protect that seedling that's growing. Because we have lost a lot of our roots, we're going to have a lot of erosion happening. You can kind of see it in this picture. You can see some of these lines going down, which is where water has been collecting and pooling as it moves downhill. That's going to take a lot of soil with it, and it's going to make it even harder for trees and other plants to grow back on this mountain face. Because you have a lot of erosion, again, a lot of soil that's going to be washing away, that's going to pollute those streams. In the valleys of these mountains, there's streams. Organisms live there. Organisms depend on those streams. But now they're filled with all of this sediment. Some sediments have a lot of metals in them. If you get too much sediment, it actually makes the water unusable. If we want to think really about the environment, excuse me, and the things that live in that environment, you just got rid of a huge piece of forest. There were tons of organisms living there, and you didn't leave anything behind. So those organisms had to find somewhere else to go. Now you may think, well, that's not a big deal. Deer can move pretty easily. You're right. But what about frogs, salamanders, some insects? Those organisms don't have that chance. And that's actually why a lot of amphibians, frogs and salamanders, toads, are going endangered and are becoming extinct. Is because when you do this widespread habitat loss, they're so small. They can't move that quickly. It's not an easy, they can just go somewhere else. That was a very far walk for a salamander, and it's not as easy as that. And then finally, this can be really, really crucial to people who are living in areas that are clear-cut, is you have more flooding. We no longer have roots in that soil, and so when the rain falls, the soil will soak up some of that rain, but that's it. It's just the soil. Once that soil is full, once that soil is now mud, that water has to go somewhere. There's no trees to soak up that water, so the water rushes downstream. It's eroding the land at the meantime, and that stream is filling up much higher than it usually is, which can affect a lot of things, particularly humans living in that area. So what's the solution to this? How do we still get trees? Because again, it's a renewable resource. Hypothetically, I should be able to take trees and then come back in a couple years and take more trees. So how do we accomplish that while avoiding these issues that come with clear cutting? So there's probably more, but the two main types of sustainable forestry we'll talk about are selective cutting and strip cutting. Let's talk about selective cutting first. So selective cutting is typically when the tree harvester has some sort of metric. For example, we'll say trees with a circumference larger than 20 inches. And they'll go through and they'll mark those trees, maybe they put X's on them, then they take their machinery and they only chop down the trees that are larger than 20 inches in circumference, and they leave all the rest of them behind. So here you kind of have this random scattering of, we got trees that are left and trees that have been chopped down. So we still have trees around to protect seedlings. We still have trees around to make seeds. We still have soil in place because we still have roots. And so the end result is that we still have this clear stream. We also still have the ability to regrow those trees a ton faster than if we just wipe them all out. If we wipe them all out, it's going to take a very long time for that forest to come back. So that's selective cutting. If we go to strip cutting, this one works a little bit differently. Instead of choosing trees by size, we are literally just taking a small strip of this forest. We're essentially clear cutting, but instead of clear cutting the entire forest, just a small portion of the forest. So you can see here, here's our old mature forest, and then we came through here and took everything out. Now if you look at these two, you can probably see that there's some benefits to each one, and there's also some drawbacks to each one. So one benefit, let's say of selective cutting, and you can actually see it in this picture, is there's barely any erosion. There's a lot more erosion in strip cutting because you are leaving part of that soil bare. But if you are the tree harvester, which one do you think is easier to actually do? Probably strip cutting. So both of these are at least superior to clear cutting, but both of these also have their drawbacks. So it's not a one and done answer. It's not an easy answer. There's really no way for humans to take resources without there being any kind of repercussion, whether that's environmentally or financially. But still good techniques in order to maintain that forest and be able to chop down trees for years and years to come. To bring it a little closer to home, we're going to take a look at forestry here in the United States. So this is a map of estimated forest cover in 1620. Obviously, we did not have all these 50 states in 1620. We just had some colonies. But based on looking at soil samples, soil, kind of like ice cores, give us some insight into the past. And so if we look at our soil cores, we can be like, oh, wow, there's seeds in here from the 1600s. That must mean there were a lot of trees here. So this map is kind of like estimated cover in the United States about 400 years ago. And take a look at this one today. It's shocking, right? Here in the western United States, we do see a lot more dots, a lot more patches, but here on the East Coast, there's barely anything. Now I show students this, and I know it's an online class, so it's a little bit harder to have this discussion, but this is not the whole picture. Take a look at the title, Area of Virgin Forest. Virgin forest just means trees that have been around since the previous map from 1620. So there's not a lot. And so you might look at this, and sometimes news articles like to show this, but it's not quite fair because it makes you think, oh my God, we have no trees. Okay, you have been driving, you have seen trees, you have seen forests. Obviously, this map is not accurate to the forest cover that you've seen. Here's a picture of today's forestry. Here is our land cover today. And I'm going to flip back and forth between today and 1620. And you can see, other than some random patches here and there, that forestry cover is nearly the same. It is less, but it has a wide expanse in comparison to 400 years ago. The moral of the story is trees grow back, especially if you're being sustainable. If you're being sustainable, that means trees grow back and you get resources every year. And that's critically important.